Hello, welcome. Yeah, excellent to have you in this talk. I think we just directly jump in. This is an international conference, so I switched to English. I hope that's okay for you. And if you want to ask questions, obviously during the talk, or better at the end, you can do so in German and English as you like. I try to relay them then back to the audience in English. Good. So Christian Schneider, my name, from Cologne, just arrived yesterday and gave already a talk on this day about security. But actually it was a session, it was a slide-less session, so easy for me to prepare. And now in contrast to that, I do have a slide-full session because we have got lots of slides here. So I think in average, that's a good fit. Good, so we jump right in. Due to the time of 1 hour, we have a fully packed talk. So I really encourage you to take care that you get this attendance sheet from the backpack or the case you got, where the code for the slide access is in it, that you can download all the slides from the excellent conference talks here, including hopefully this one. Good, so jump right in. A few words about me. I'm a software developer. I started at least as being a software developer, and I got into the IT security area quite early, which means I do lots of penetration tests, lots of security reviews, consulting, all these things. And I always see the same things in the same manner of fails in terms of where security things are not good, or some applications are vulnerable, some things have been neglected, and this can be clustered to some kind of, let's say, 7 or something typical scenarios of where things are missing that should be usually there. And I'm a little bit sick of finding always the same issues and same things, so I try to present them in a talk and put them in the slide deck of, let's say, don't tell you how many slides I have, over 100, and to present you those 7 clusters, the 7 security sins, and that's basically what we're in here, to get to know these 7 sins, so let's call it problems a little bit better in terms of what should be done. So we get into this quite directly now. These are the 7 security sins, and we go one by one through that kind of mind map. And we've got 2 or 3 rather bigger ones. The first ones, bigger in terms of times, or in terms of time that I take for them, more details. And the remaining ones are the easier ones to explain. So let's start with this one. What could this be? It's the missing of whiteboard hacking. Thinking like the bad guys. So this usually starts with threat modeling. I see these things missing in agile projects quite often. So how many of you are doing threat modeling or have done that in the past? 1, 2, 3, 4, 5. That's not really, let's say, what I expected in terms of this should be done quite often in order to have a big leverage on where and when you find security issues. Because when you do this on the whiteboard, on architectural level, you do have some kind of time-saving way to fix this, because you do not have any code that needs to be fixed, because you're doing this on architectural level. And quite well known, let's start simple. Stride, this is something that came from the Microsoft area of their secure development lifecycle. It's a matter of having a set of 6 categories where threats may come from into your architecture. Spoofing, tampering, repudiation, that's the letters here. Information disclosure, meaning accessing information as an attacker that's not intended to be accessed. Denial of service, that's could be definitely expensive for a shop. And evaluation of privilege. So this can be done, this kind of threat modeling, using tools like you see this Microsoft threat modeling toolkit here. It's a free software available from Microsoft, much like Visio, where you basically draw your architecture, but you model that in a way that you do a semantic modeling, so it understands how your architecture works. So you do have different entities here in my demo setup here, and different kind of connections. And these connections do have some kind of file formats or data formats or data exchange formats, and they do have some kind of properties. And on each of these entities and connections, you can set up and fill some kind of properties here, like whether it's encrypted, the communication, or not, or whether it's authenticated or not, or whether the storage is encrypted or not, and stuff like that. So it understands what you're modeling in terms of how your architecture consists of stuff. And you see those red boundaries here. These are actually trust boundaries. So that's where the outer world sits compared to your system. That means the evil internet or some kind of other systems in a properly network segmented thing. And then this tool can, in analysis mode, directly get security vulnerabilities or threats actually that might come from a vulnerability not handled properly or from a hardening aspect that has not properly been done into your application's architecture. So you get ideas and reports from that, what you eventually need to consider, like fixing potential vulnerabilities, doing more input validation, doing more encryption, stuff like that. So you get an understanding by letting a tool get the typical vulnerabilities and threats out of an architecture for you, just by modeling. That's nice. Free tool, Microsoft Threat Modeling Toolkit. But that's not the only one. We do have more in that area. Commercial tools, tabular-oriented ones, diagram like this one, oriented ones, etc. But probably the best one is just pen and paper. So it might really make sense to put you on a whiteboard in the architecture of the software and just discuss about that in terms of where do we cross trust boundaries, where do we have some open edge on our system that we need to protect more when the attacker is in. It's all about you thinking about your architecture, not about a tool, just one example. Also, in that kind of sin, we do have hacking the backlog. That's missing. I see this kind of hacking the backlog stuff not happening too much and too often. That's definitely sad. And I speak about evil user stories. So how many of you are doing or have done evil user story things in terms of software architecture? No one. Two. Okay, so that's definitely something you should do more. By evil user stories, I mean the same in agile software development. It's like a user story that you have in your backlog, but here you learn the motives, the motivations and the intentions of hackers. So you might brainstorm ways that a hacker can achieve certain goals in your architecture, in your software, once he's in, or how he gets in. And the same is true with evil user stories as with classic ones. You refine them. So they stay in the backlog as a rather abstract one, and they can be refined in order to get security requirements out of them in order to combat or avoid those vulnerabilities. So one more business-oriented, very abstract formulated evil user story could be, as a hacker, I want to modify prices in the online shop so I can buy products for free. Nice one, but this needs to be refined in some kind of more elaborated way in the backlog, like a regular user story. And this could come up with something like, as a hacker, I want to intercept in my browser the payment provider's back redirect to the shop so I can decline payment during checkout with the payment provider, but pretend to the shop payment was successful. And when the server-side check, which is obvious and mandatory, is missing, then basically it might be that the API thinks that the payment was done, but it wasn't done, and you get some stuff for free. So that leads to the very easy to explain security requirement. A more technical example, second one. So as a hacker, the abstract version, I want to attack the data import routine, whatever that is, so I can further get access to sensitive content. Could be some import of some files or some XML or something like that. This could be refined in the backlog to something like, as a hacker, I want to put an XML external entity payload into the XML document that gets imported, so I can read files from the backend server's import processing microservice. The security requirement that can be deduced from that is hardening of the XML parser. So you see how these stories might fit, when you discuss about that, into your backlog in order to get a nice way of coming up with security requirements. And that's exactly the next part within that sin of missing whiteboard hacking, that you do not have enough security requirements in your backlog or in your architecture. They can come from evil user stories, just like we did with those two previously. They can also be coming from threat modeling, like we showed that as well. They can be coming from security architecture reviews, or they can be created by playing a game, also very interesting. So by playing a game, I may mean something like OWASP Cornucopia. How many of you knows that? 1, 2, 3. Yeah, that's a card game actually, like a classic card game. You can get those cards from the OWASP organization, or you can just print that out as a PDF and then you can cut them out. And it's a way to play as a team a game about the security requirements in your software development project. And it's like a regular card game. You do have different colors, and they are the categories of authentication, validation, for example, encryption, cryptography, authorization, session management, stuff like that. And you even have white cards. And it's like in a regular card deck from 2 to 10, and then the other cards, including aces, for the very extreme vulnerabilities. And you play this as a team. The idea of that kind of thing is to have a team discussing potential issues about their software. So that should be something security should be interested in. So they should bring some pizzas and some prizes. Makes sense. And you score points when you play an attack as a player, when you play a card that is, in theory, something you should consider in your architecture. Could be totally out of scope, but it could be something, well, we need to discuss this. Then you play basically that kind of card and get the points. And this can be discussed in the team, and the player at the end with the most points wins. Basically, it's all about the team, including the product owner, if possible, discussing potential attack vectors by playing a game. These cards look like that. So you do have in the category of authorization that something can be misused. It's a 9 or a 7 in data validation when you can bypass some kind of input validation routine, or in the wildcard category, cornucopia, or something interesting, or in the cryptography category, some not very well encrypted data, for example, or session management, stuff like that. So you can play them like regular card games. It's really fun. There's an alternative, as always in life, from Microsoft, which is the elevation of privilege card game, yielding into the same direction. Also, what I see often is that teams or projects are not benchmarking themselves. Benchmarking themselves against best practices. This could be done on a technical level, like the OWASP ASVS, Application Security Verification Standard. It's basically a bunch of, it's a PDF, a bunch of categories, and sorry, a bunch of checklist items you can check off. And you do have a target level from 0 to 3, how good you are. And these are the categories. So you do have categories, again, like authentication, session handling, file handling, logging, mobile stuff, web services, whatever you can think of, architecture. And each of these categories has many items, and those items, depending on what level you'd like to score, need to be fulfilled. And if you do have some gaps, depending on your target level, how secure you want to be, then basically you understand from that kind of checking of the checklist where you eventually need to come up with more hardened security posture in your application. And you get links even to the OWASP and other resources that can be used to get the technical details of how this can be achieved. But by benchmarking, I mean not only technical level, this can be also achieved on company level. So how good a corporation is. And again, we do have something from OWASP for that. It's the Software Assurance Maturity Model, the Open SAM from OWASP. Here we do have some kind of categories like governance, construction, software creation, verification, or the testing thing, and operations. And you get some subcategories, and in each of these categories you do have at least those 3 levels, 1 to 3, and the objectives, how good you are, depending on what you're doing and what the next step could be. So here the idea is to get an understanding of where you are in that kind of, how as a company are we handling security, and what could be the next easy to reach steps. Good, so that's it for the missing whiteboard hacking stuff. Now we go into the next category. What could this be? Firewall, yeah, it's good. It's missing security architecture. So I think that was quite good in terms of security architecture at the time it was built. At least it looks like that, and survived quite long. And I see some projects, and many projects fail to have a good security architecture, especially agile ones, built from within. And first thing in that kind of category, sin, is crypto. We really need good cryptography. We do need good crypto. Why do we need that? Because data gets leaked from time to time. And if it gets leaked, it's good when it's encrypted, at least. So on AWS, for example, we do have lots of S3 buckets, and there's an attacker's offensive tool here that can be used to find publicly reachable Amazon S3 buckets. So open S3 buckets with eventually interesting things in it. You don't know. Another tool is existing. Second one. Third one. S3 scanner. So must be a market for tools scanning the interwebs for OpenS3 buckets. I don't know. Nice one is a list of AWS S3 leaks. So NSA leaked something that's interesting. Even NSA fails. Uber leaked stuff. Here credit stuff leaked. 120 million American household data exposed. Sensitive medical records leaked on OpenS3 buckets. Julie's medical records just from March. And this list is going to be extended, I think. So any kind of cloud, whatever you use, needs to be configured correctly. And AWS has good tools for that, as well as others have. But if you're not using that, well, that might be some misconfigured thing. Having an S3 leak is stupid, and having that with sensitive data unencrypted in it is really stupid. So you need to have good cryptography. Shodan also very nice. It's a search engine like Google for websites. Shodan is for refrigerators and other things you put on the internet, IoT, Internet of Things, including those industrial control systems. So if you find open ports of any kind of, industrial control system, that's something that can be abused, like also unprotected databases. Amazon or any other kind of cloud services hosted databases. If you do not configure them correctly, or if you host them on your own, it could be that you might have them open and leaked somewhere, like MongoDB or Postgres data. So you can then search for country and get into the details and get access to these things. So this IoT teddy bear some time ago leaked 2 million parent and kids messages, voice recordings, in an open, unprotected NoSQL database, just sitting on the web, easily indexed and found by Shodan. So you really don't need to hack to get access to sensitive data. You can just do the due diligence to use the search tools, and you find these. That means we need to have data encrypted in it if it's sensitive. So if it gets leaked to some kind of configuration error, things can happen. At least the sensitive stuff is encrypted. So good crypto really helps. And when I focus here, the CTO from AWS, he's done the best slide ever. That's really pretty cool. So they know how to do it, and we just need to use it. And that's what we are here for. So it's dance like no one is watching, encrypt like everyone is. Good slide. What kind of crypto shall I use? Well, good one. Depends, as always in life. Symmetric, asymmetric, of data in transit, data in rest, etc., but not use ECB. I've seen this too many times. Don't use ECB mode. That's the encrypted version of TUX with ECB. Also, don't use CBC. No. If you think about symmetric cryptography, I'm not going into the details. It's basically a way to attack the padding. We are a padding oracle attack. What you should use is, and that's the important thing, GCM, Galois counter mode on your symmetric crypto as one of those block modes of operation. That's the best one to use. If you are a little bit dazzled by these abbreviations, there's a good publication from BSI, Bundesamt für Sicherheit und Informationstechnik, about cryptographic algorithms to use and how to configure them correctly. So they are recommending some key lengths and crypto algorithms that you should use depending on what you're doing and trying to achieve. That's a good way. What they're recommending, that's quite good. We do have some equivalent from NSA as well. What about randomness? Randomness, I see always this fail in many security reviews. Don't use Java util random only for game playing stuff if it's not monetary relevant. For anything else in terms of security, try to use, if you can, Java security secure random. Both results look random. One is better, the other not. So for the Java util random stuff, if I observe enough samples of that random data, I can calculate back the original seed, and then we can get all the correctly predict all the random data. So it's not random at all. Security secure random is trying to always use as best as possible the entropy pool of the machine. And where do those machines get the entropy from? User machines get it from user actions, how you interact with the system or with the phone or with the keyboard. Servers get it from some kind of other external environment. Even radioactive decay can be used there in some professional systems. And Cloudflare, that's a very nice video to watch. You can do this later. They are doing it with lava lamps. They are monitoring, they are photoing, videotaping exactly the lava lamps, and they are hashing them, and then they have some seed for the entropy pool because they need to have lots of good random data for all the SSL certificates they are offering. quite nice. Good way of doing it. So HTTPS needs good crypto config. There's a self-scanning that you can use just on the internet. Check the do not show the results on the bots checkbox. And then you can enter any URL and you get an understanding of how good or how bad in terms of SSL, TLS endpoint your website is. That's easy to do and easy to check. A+ would be perfect. Also missing in security architecture, I see the missing of vaults. How many of you are using vaults? Well, that's better than expected. I think 30%, that's good. Great. For the other 70%, you should always do this as well. So why? Because passwords get leaked from time to time. And that would be nice if you are having a vault, then yours won't be leaked. So there's the exploit database available. That's a very nice site on the web, exploit.db, where you get exploits from, which is actually attack code. But I'm not interested yet today here in this attacking code stuff. Here we do have the Google hacking database sitting here. If you click on that, you get exactly this. It's a list of categories where you do have very nice Google dorks. Not dogs, dorks, D-O-R-K-S. A dork, Google dork, is a very well-formed search string you can put into search engines like Google, for example, utilizing their nice search syntax and yielding you interesting, juicy stuff. So error messages leading eventually to vulnerable systems, here vulnerable files, existing files known to be vulnerable, sensitive online shopping files containing juicy info, files containing passwords. So we do have almost 300 Google dorks, good search strings for finding passwords on the internet. And here, one example. Good search strings in your Trello. Okay, yeah. What do we have? We can do a search for this. File type env, intex, Redis password, and then you get, you can think of. Just don't put it on the net. It has been indexed by Google, and you can do a search for that. And you can scope this to your target URL you would like to attack, your company name you'd like to attack as a hacker, and then, until you're in and get access to data. So passwords do get leaked, therefore you need to have good vaults. Spring Security is a very nice Spring Vault. The Spring Group is offering that, even with a Spring Cloud Vault way of doing it. Basically, it boils down to that your code doesn't have any passwords. Obviously, it shouldn't be hard-coded, but also your config files don't carry them. It's that you inject them from the vault. And there they are residing in a good, cryptographically strong, protected way. So yours don't get leaked that way, don't get indexed on Google and other search engines. Also, I'm seeing missing in the security architecture scene proper identity propagation. And this is especially true for microservice architectures. So the backend is no longer considered fully trusted. It's nice if it's fully trusted, definitely, but we cannot rely on that. So we must take some architectural patterns that a microservice can eventually, distrust the other microservices a little bit. There's not a requirement that our backend needs to be fully trusted. It should be definitely fully trusted, but it's not something we need to rely on to be safe. We must even be safe if it's no longer fully trusted because an attacker is in it. It should be safe even then. And this can be achieved by having something we call in the IT security area identity propagation. So it's basically all a way of propagating down the identity of the one who's sitting in front of the browser, app, rich client, you name it, IoT device, through all the backend layers, through all the different backend microservices. Even when microservice A is calling microservice B to do something, microservice B should be aware of who or what is sitting in front of the client. And that can best be done. You have multiple ways of doing it. One way, and this is something I like personally very much, is to use JSON Web Tokens. So JWT, just have some kind of cryptographically signed token encoded with information in it about the user sitting in front of the client. And that can be passed along around every microservice in the backend. It's cryptographically signed, so it can, from the identity provider after authenticating, something like JBoss Keycloak can be used, something like that. And then each and every microservice can autonomously check the token, whether it has been tampered with or whether it has expired. And if it's valid, it hasn't been tampered with, not expired, then it can pull out the data. And the data that can be pulled out can be custom claims. So the properties that best describe your user, what tenant it is, So that's not able to access data for another tenant, or what sales area, sales figures may be viewed for. So that if some hack has been performed to view other sales areas, sales figures, the microservice delivering these numbers can say, well, I'm going to give you the numbers, but your token doesn't match the request. Somehow you hacked this system and I'm not giving you the data. So it's a way to propagate down the chain of the call graph, the identity of the user, and this can be best done and achieved by a token. And this obviously requires, I see this so often failing, proper HTTPS with a PKI in the backend. So you need to have some kind of public crypto or public key infrastructure in order to have cryptography properly in the backend, so that you do have some kind of protection of data in transit. Otherwise, again, you would fall back to data that the backend needs to be fully trusted. Otherwise, you're unsafe, and that's something we can no longer rely on. Also, I see in the security architecture thing, I'm missing hardening. And by missing hardening, I mean of the infrastructure you're running on. Anyone using Tomcat? Yeah, the majority. And I like that very much. A good container. Hardened it? Just a few. Anyone using Docker? Yeah, also many. Hardened it? Just a few. Kubernetes? Nice. Hardened it? Hands go down. AWS Cloud? Good one. Hardened it? I could play this game for way more. Anyone knows CIS benchmarks? There the hand should go up. That's definitely something you should use. The CIS Center for Internet Security benchmarks. That's their homepage. It's a way to benchmark your system, your infrastructure, your configuration, your runtime against best practices in terms of security, how to harden things. So if you were to click on the benchmark link here or there, you get a list of benchmark downloads. That's basically a bunch of PDFs. And those PDFs give you some kind of hardening tips. So for many ways. Amazon stuff, AWS, web server, Apache, Tomcat, operating systems, Cisco device, CentOS, DNS, Docker, Google stuff, Microsoft's cloud stuff, Kubernetes, very nice, etc., MongoDB, Oracle DB, Oracle Linux, etc., MySQL, etc. So if you get one of those benchmarks, it's a PDF. And in that PDF here, for the AWS stuff, you do have many chapters with many hardening tips. So categories like identity and access management, logging, monitoring, what do we have? Networking, and over 155 pages just for hardening or checking AWS in terms of how good your hardening is. And each of these chapters has the same pattern. So in the benchmark, you do have a title, obviously, and whether it's scored or not in terms of a review, and a description. What this item means, a rationale behind that, why you should do that, and a way to audit that, and a way to do a remediation if your audit says that you're not doing this. And you get even further links. So for Docker, that's even pretty awesome what they did. So for Docker, you do have a host configuration, Docker daemon configuration, Docker daemon config files, container images build file, container runtime, and Docker security operations, and Docker Swarm configuration in it. So over 200 pages. And you even do have command line options to check and to remediate. Great stuff. Only downside, over 200 pages. No one will read that. And for this, we do have tools. So officially from Docker, in their Docker repository, we do have the Docker bench, hence benchmark, Docker bench for security. That's basically a shell script with a little bit more that you execute, and it does all those checks for you and gives you the warnings here in red for the chapters where you then need to do the lookup in that kind of PDF. So you can read in the PDF then the chapters you think that are worth hardening. Nice. So an audit tool. Anyone using Oracle databases? Yeah. Anyone hardened that? Yeah. We do have DBZ. Oracle Database Security Assessment Tool. Once you have Oracle licenses, you get that for free. And there you can do some audit of your Oracle database server as well, whether it's hardened enough to your target or not. Oh yeah, nice one. Secure config. I see so many configuration fails in my penetration tests and reviews. Unfortunately, I cannot present them. Well, that's not something pen testers do. It's against ethical hacking and NDAs. but we can do something on an analogy here. So even simple things like webcams, those little cameras, internet cams, are so often misconfigured. Now imagine a full-fledged server infrastructure being somewhere misconfigured in terms of security. By cameras, I mean that they are unintentionally placed on the web, and there's a nice site for that where you can just do a search for interesting cameras that people put on the web and eventually misconfigured because they are totally open. I think this bakery here didn't expect that. It's publicly indexed in the search engine, or this kind of shop, or the restaurant, elevator in a hotel, not this one, from the outside, and you get the camera from the inside. This is some kind of shop in a mall, something like that. Also some kind of hard work. Oh, interesting, that's some kind of office. Oh, workers' council, you're videotaping your employees. Some kind of university room. Also some kind of hardware, different style. I don't know what that is. And that's also some hardware. So lots of stuff there. Now imagine the potential of a config fail, not only for a similar or simple web or online camera, but for a full-fledged enterprise application server database, you name it. That's pretty devastating eventually. And that's why we do have in the current OWASP top 10 the A6 entry security misconfiguration. So yes, please check your configs. Do the hardening checks and check your configuration. What I also see missing is often secure coding in that security architecture sin. So for secure coding, well, we do have guides. They are concise, they are readable, not the shelfware you just put in the bin. It's OWASP proactive controls, a list of 10 things you can drill down, a list of 10 things you should do correctly as a developer. So in terms of how you treat input, how you validate that, how you encode output, how you parameterize backend access, etc., even logging and stuff, etc., etc., etc. Or so-called cheat sheets. You remember from the security requirements we got to harden the XML parser. We got that from the evil user story, that the attacker would put some XXE payload into the XML import routine and get access to sensitive data. And the outcome of that backlog item was a security requirement to harden the XML parser. How can we harden our XML parser? Here we do have a list of cheat sheets from the OWASP Online XML External Entity cheat sheet. We can click on this. That's the cheat sheet how to harden your XML parser against this very critical attack. So for C, C++, Java, different styles of parsing XML, .NET, it even goes to PHP and iOS and stuff like that. And it gives you the hardening flags you need to set on your XML parsers instance in order to ensure that you are having a secure one. Well, that's simple. Even Oracle has very good secure coding stuff for free available since always, but we're not using it, unfortunately. So it's good, it's there. Secure coding guidelines for Java. Many categories: object construction, mutability, input validation, serialization, that's my private fun category, and stuff like that. And you got lots of good tips, including code samples, how you can securely write code and software that way. So I see these things missing in projects, leading to security vulnerabilities. Also protection headers, simple to achieve, low-hanging fruit, but should be there. We do have an OWASP secure headers project that can be used to give us insight into the different security headers we need to set in the wrap response in order to do certificate pinning or to do XSS protection, X-frame options, stuff like that. Simple stuff, not protecting your application security vulnerabilities, but protecting some of the easy to see and exploit low-hanging fruits. So that might make sense. To use that, there's even a site where you can just enter the URL and tick the hide results checkbox, and then you can get a sample of how good or bad your response is in terms of the security headers. Good. So this has been the security architecture, the missing security architectures. And what could be the next? This one. It's missing security automation. Because things can be automated. Checking things and finding vulnerabilities doesn't replace a penetration test, but it's always something that scales. So application security scans, that should be done. And I see this missed in so many projects as well. And what can be automated? We do have 3 types of security scanning tools or security checking tools. We do have DAST, Dynamic Application Security Testing, SAST, Static Application Security Testing, and IAST, Interactive Application Security Testing. So for DAST, that's the fun part, basically scanning from the outside. So I did a session on this this day a few hours ago, where you can see this in action. So it's like a scanner scanning the web endpoints and trying to find vulnerabilities. Static application security testing on the other side is taking a look at the inside, at the code, bytecode or source code, whatever it is, and checking for anti-patterns, for vulnerabilities inside the code, security things. And interactive application security testing tries to be some kind of blend of those two mechanisms. It's a way that you instrument your runtime environment, can be your Java or .NET runtime or whatever, with an agent from these tools, and then you basically do some scanning from the outside, and at the same time, the instrumentation, bytecode instrumenting agent looks from the inside. Also very nice, having those two things combined. In terms of commercial and open source tools, we do have lots. The commercial ones are sometimes quite expensive, but good. Sometimes a little bit too expensive. And we do have open source tools in these, at least those first two categories as well. In the last category, only commercial tools are sitting. Anyone of you using any of these tools? DAST, SAST, IAST? No, let's say 5%. Oh, nice. Preferably as part of a build chain. I gave a demo for this just 2 hours ago using the open source tool OWASP ZAP. We do have better commercial ones, but that's the best open source one. It's an intercepting proxy, so you can just spin it up headless or using some user interface somewhere when you do it manually, and it can proxy the traffic that it sees, like a regular web proxy, HTTP and HTTPS, and then you can use any kind of test traffic generating component. It could be a Selenium test, UI test, could be some REST client tests, whatever you use. And it's then in this kind of operation that you use it, scanning and attacking on the test system usually, otherwise it would be illegal if you do not have permissions. On the test system, it's scanning and attacking the backend or the server for all the different kinds of vulnerabilities we do see in the web security area. So it does have a user interface, looks like a browser console, but has also a headless mode. I've seen this in action just 2 hours ago in my slide less talk. And here we do have some architecture to set this up as part of a build chain, preferably. We do have some Jenkins or what kind of build server you use, running some build scripts, Maven, Gradle, you name it. And you're executing user interface tests using Selenium or service tests using SOAP or REST clients. Both of them, either directly or through a WebDriver, are generating HTTPS traffic. And you just can run this open source tool in headless mode and proxy the traffic through that. And while it's proxied through that, it's actively attacking it. And then you can get the reports out of that. So it's a very nice setup. We even do have an official Docker container from OWASP ZAP. For the SAST part, static application security testing, we do have find security bugs. That's in the open source arena for Java, at least one interesting candidate. That's more the area of commercial tools. And that's a good one, find security bugs. It's a plugin for find bugs. So a plugin for plugin. So everywhere where you run find bugs, you should execute find bugs with find security bugs in it. It finds over 128 different bug patterns, security bug patterns, very good, and gives you some kind of output as XML that you can process further or as some HTML. It can execute as part of your build, so you do have everywhere where you can execute find bugs, you can augment that with the find security bugs plugin, so it can be run in Maven, Sonar, Jenkins, in your IDEs of choice for Java, even as a command line, that's the catch-all. And if you execute it in the IDE, you get some code pointers and some kind of vulnerable spots here, vulnerabilities, code pointer. When you click on it, a description. That's pretty nice. And for .NET, we also have tools like that. Secure code scan is one open source one, very nice. Using these tools, DAST, SAST, you can come up with something like that. That's a slide from Aaron Viva from the OWASP Foundation. Basically, here you create here some kind of RUG DevOps pipeline where you can intake some kind of vulnerability scanning target, like a application or REST endpoint or whatever. Then those tools, dynamic and static, can somehow try to find vulnerabilities, and then they are pushed towards defect trackers, and that's something we see now. Because what you do with those different kinds of outputs, well, it depends. When you do have multiple tools generating you multiple outputs, multiple reports of security, you have multiple truths. and you want to consolidate them. So when you're in the luxury position to have those multiple scans, dynamic and static, done on your software automatically, might make sense to consolidate them. We do have vulnerability repositories, some kind of software, server software that you install on-premise, and that can take the native report formats from all the commercial and open source tools and consolidate them, deduplicate them, give you some way to handle false positives, give you some way to have some trends and graphs. And that's a nice one, open source one, Defect Dojo from the Open Web Application Security Project. You get nice dashboards, and you can even funnel them into bug trackers, Jira, Bugzilla, whatever. Good. Dependency management, also something we should automate. And I see this missing so many times. Show me a web in Flip and I tell you who you are. So many dependencies, including the transitive ones in it. Anyone remembers Equifax? They didn't patch for 2 months a critical vulnerability in one of the web frameworks they were using. And this cost Equifax $600 million US. This data breach? No, wait. It's now $4 billion US. So this was a massive one. They leaked over 148 financial information and social security numbers. So over 40% of the US citizenship got their private data breached due to them not patching one of those little things in their web and Flip. So for 2 months. This means we need to have some kind of check for this. And there's the OWASP dependency check, something we should use. It's again, open source, nice tool you can put as a build plugin into your build pipeline, or you can run it as a command line interface, however you would like to do that. Just run it. And what it does, it checks all the CVEs. That's the list of CVEs. Here, that's another third-party site where you get insight into CVEs. A CVE is basically an ID for a vulnerability in some widely used software or component, framework, library, server, you name it. And you can do a search online in this kind of CVE stuff to understand what of your frameworks have vulnerabilities, and OWASP dependency check is doing this automatically. So it downloads all the CVE data from Mitra and NIST, and then it's doing some kind of fuzzy matching of your dependencies onto those CVE stuff. So you should check your production branch nightly. I see this fail also many times. Good that you're doing nightly checks, even when you're not committing actively, because you're still vulnerable eventually on the internet. But I see many projects that are only checking the development level, the development branch, which is good because then you can fix things early. But on the production branch, you might be a little bit older, still being more vulnerable, having the not patched things. So you definitely should run this kind of tool against some branch in your CI system, doing some kind of build of the production version to check exactly these dependencies. Also, I see very often missing in the security automation, sin the missing of secret leakage prevention. Secret leakage prevention. Oh shit, Adobe. In 2017, September, the security team of Adobe decided to accept vulnerability information about their products, even in an encrypted email, so that hackers, good ones, white hat hackers, can mail them using some PGP encryption in a very secure way what they found that they can fix this. And in order to achieve this, Adobe put their PGP key, the public key, on their security team blog. Including the private key. Got revoked a few days later. So that's basically one example of many ones I can tell you how secrets might accidentally get leaked. Obvious one. I see this often in public GitHub repositories. So we even do have nice attacker tools to find these secrets and pull them out of GitHub and other kind of repos. So we do have GitRob. That's a tool that can scan a GitHub repo for sensitive, juicy things, accidentally sitting there, even the history. Or doing GitHub dorking, like the Google Dorks, we already had them. This can be done in GitHub as well. So just put this into GitHub. Don't do it. File name, credentials, AWS access key ID. Giving you that. What we see here is just search for that thing here in the search box. We do have interesting, juicy stuff, so that's definitely something we could use. Do not keep this file in your source directory, says the comment. And we have over 10,000 of results of that. And this is just one GitHub dog out of many things. So I see secrets accidentally get leaked, even in repos. And even if you remove it, the history still has it. So we do have meta tooling for that can do the scan using multiple tools, a tool to capture all the Git secrets by leveraging multiple open source Git searching tools. Nice. So how can we defend that? At least use good git ignore files. There's a good collection of good git ignore files for many different technologies. And also use commit hooks on your clients to prevent the unexpected. And that's a good one from Amazon. I really like that. AWS Git secrets prevents you from committing secrets and credentials into Git repositories, especially focusing on these AWS key IDs and other stuff. So it's a command line commit hook you can use so that you commit fails locally before you push it to the upstream things. And it even has a Git secrets scan history thing to scan your history when you decide that we are now open sourcing this cool software, including the history. And yeah, this is scanning if someone in the history has accidentally committed something sensitive and then removed it, but it's still sitting in the history, might make a good catch. And also treat this one as one more reason to use vaults. Definitely don't put any secrets in code and config, put them in vaults and inject them using something like Spring Vault or something similar. Whoa, these were the three most lengthiest ones. What could be this one? That's a quick one. The missing of offensive penetration tests. The manual stuff, pen tests. So how many of you are doing regular pen tests? By regular, I say at least one time a year, just 5, 6, 7, 8%. And this should be done more often. And why you should do it? Because manual tests will find the unexpected things that no tool can ever find. I want to have the tools executed before I do the penetration test as a pen tester so that I do not need to bother with all those automatically findable things. And I can go for manual things like business logic failures and stuff like that leading to security issues. When you do it, well, for major releases, for changes in authentication authorization, when someone recommends it from the team because they know it, these are all indicators when you should do or ask at least for an external penetration test. Good. So what's this eventually? Next sin. The fifth one. Missing organizational change. It's also a matter of organizational process to be secure as a product. Security role in every team. So definitely even, or especially in agile teams, we need to have security roles within. We do have the testers, we do have the ops people in it, and we also need to have some security people in the teams. Better use one of the team members doing the coding as well and give them some more training in terms of security so that they understand how these tools work. They do all the nice automation things. How to handle the security scan results. So how to fix things, can do the triage. Is it a false positive or not? Can influence, because it's coding and defining architecture as the team, can influence also these security people, the architectural decisions. Early on, do the whiteboard hacking stuff, threat modeling and stuff like that. Coaches the developments to fix and vulnerabilities and create secure software. And very important for big organizations, that's a bidirectional contact to the central security department. So security department can use the security people in the team on some monthly meetup to push some kind of new stuff to them, current vulnerability things, and they can ask questions to these security people then at that central meeting, the security department, where they can then get something solved that would not otherwise be solved by the team. And this also means we need to have some kind of room for this in the sprint planning and other things. And that means we need to take the product owner into the game. See this failing in agile projects so many times. We need to make the PO, the product owner, aware of security risks. We need to have dedicated security sprints. That's something that costs money. Yes, it's a matter of budget. But the PO needs to understand that it's not only about features, it's also about security, because otherwise no feature is worth anything if data gets leaked. That can be very devastating. So sometimes those tool outputs leading to some vulnerabilities we need to fix might lead to a security sprint dedicated only fixing security things. Sometimes. Might make sense. And on the long story, it might make sense to make the security requirements part of your DoD, the definition of done. So when your team says, now this kind of user story is done, that means you have checked the tool output and ensured that at least no critical findings have been found. Good. Also, this means it's a matter of changing the process and introducing some responsibility into organizations to get this organizational change. So it's a way to define and live as an agile team how tool outputs are handled. Well, eventually using these vulnerability repositories. Because if a tool says something and no one cares, I've seen this so many times, aging findings. So who triages the finding? Who's in charge? The security people in the team can be, in order to decide whether it's a false positive or not. Define a process for that. And also, simple, so execute and follow one, best practices. And also when critical and not so critical findings needs to be fixed so that they are not overaging. So that you have some kind of escalation if a critical finding is not fixed in the next 3 sprints or something like that. And that also means you need to have in an organization some kind of centralized security information hub, some kind of web wiki page on the intranet, whatever you think could make sense there. Wikis are good for that. That is the one spot, the one single spot of application security information for the organization, for the teams. Like a portal for security stuff. You get current content like current circulating hacks or something that's exploited in the wild that you need to take care of, or some tips to handle current new vulnerabilities, guidance for fixing the classic ones, how to fix this, how to fix that, documentation for the tools, how can you use the code scanning tool or the DAST scanning tool in your project, having some FAQs there, secure coding guidelines, all of them very well maintained and centralized in a single spot. And do the review. Also, security code review, very important. So, at least for security sensitive things, part of the DoD definition of done should be, has been peer reviewed in the team, eventually by the security people there. So, if I were about to attack this, I would try this and that. How is the code handling it? This is something you should be asking yourself and your colleagues on the review, when you're doing code review, from the security perspective. Woo, 2 more missing. What could this be? Fighting back. No, it's not fighting back. It's about training, staying strong, continuous training. Missing the sixth sin is missing of continuous training. And by continuous training, I mean everyone, audience targeted. So for business analysts and product owners, this is more about awareness. And then you get security. That's the benefit, that you get security requirements out of that. And the room for fixing things like security sprints. Architects should be trained as well on hardening on component level, threat modeling, understanding where something that's crossing a trust boundary, we need to have some authentication authorization checks, we need to have some crypto and stuff like that. Microsoft Threat Modeling Toolkit. And for the developers, classic stuff. You need to train them in secure coding and also into fixing things. So that leads to better fixes that cannot be bypassed, and obviously to less vulnerabilities upfront. Testers and QA people need to be trained into using these tools that you can establish into your corporation, so that vulnerabilities can be found earlier. And ops teams, obviously, less infrastructure risk. Hardening of the containers, hardening of the runtime environments, and those leakage prevention stuff. Also, in missing continuous training, I see very important, is to know your enemy. Knowing your enemy. So it's a paradigm shift for developers. So let developers perform guided hacking exercises. Guided. Where you do have on a test system or some kind of setup system deliberately vulnerable. So it's some kind of isolated, good environment to do that. But using this development, I do this in my trainings so many times. If you want to do something like that, go to the workshop on Thursday here, where you teach developers to understand the offensive side. So then developers think differently about what can be done and cannot be done with untrusted, tainted input. So it's also more of input validation stuff coming out of that by side effect. This can be achieved even in gamification scenarios, something like capture the flag events, CTFs, where we can prepare some hacking games with some vulnerable things, with a scoreboard. But also this can be done using team competing security code reviews, but this needs to be ensuring that it's not about blame, very important. Or using quiz-style gamification, something like that, game of hacks, pretty nice. So it's a timer running up and you do have some kind of vulnerability in this code and you need to click on what it is and then go to the next level and then you get some kind of score. Nice, really fun. What's the last part? 8 minutes left. Missing breach preparation. Assume breach. We are in 2018, so hacks happen. We need to be definitely aware that hackers can be at any moment in time into our system. Backend is no longer fully trusted. Some stats, just quickly going over that. Most companies are taken from the Ponemon Institute, not Pokemon Institute. Most companies take over 6 months to detect data breaches. Financial firms take an average of 98 days to detect a data breach, and retailers can take up to 179 days. 50 attacks per month, etc., and increasing, and some figures, how expensive this is. You can think of this by your own. It just, well, can be very expensive. We even have a gray market for all kinds of vulnerabilities, where you can sell as a hacker a vulnerability, and this can be resold or repackaged to something that other people might get. This is for law enforcement companies, but different thing. So, long story short, the classic parameter thinking is no longer enough. Parts of the security effort definitely needs to go into detecting successful breaches. It's not only about protecting and preventing, that's still very important, but some small amount needs also of the security efforts go into detecting successful breaches and not only into prevention. And this means logging and monitoring. We do have CM solutions on the market, security information and event management. These are tools installed in on your systems, on-prem and production, and they are having lots of different intakes, like logs from your application servers, logs from your firewall, logs from your proxy servers, logs from the database, access logs, application logs, data amounts, traffic amounts, whatever. It's like garbage in, garbage out. The better you feed it, the better it can deduce information from that. So it's some kind of more or less close to real-time correlation of these different kinds of inputs, with a little bit of machine learning in it. It's about pattern matching, so that works here. And to understand and see, that pretty much looks like someone stole or steals some data or broke into a system. Because the traffic amount from the database server to the outside world is increasing. A firewall log was trying to block an outgoing reverse shell from the attacker. And we did see lots of SQL exceptions in some log of one of those Tomcats. And now they are no longer throwing exceptions because the attacker is already on the database server. This is something just by inspecting logs can be seen by these tools. So we need good logging. That's our responsibility as a developer. And sometimes this can be not so easy that we're still compliant, but it's possible. Security relevant logs means we need to have good logs of access logs, firewalls, DNS even for data exfiltration and stuff like that. Good. Of course, don't log sensitive stuff. This is a quote from Twitter security. Due to a bug, passwords were written into an internal log. They did introduce some kind of generic request logging and accidentally logged all the request data, including passwords, but they found it themselves, good one, and cleaned up. You can even augment SIEM products with OWASP App Sensor. That's a nice one. It's an application intrusion detection system that you can put into your code, a component that's basically counting, and you can just say, input validation failure, +1, database exception, +1, missing permission check, whatever, missing authorization, +1. Wrong username or password, missing authentication, +1. And it's basically giving you a way to throw all these +1 into these OWASP App Sensor in your complete architecture, even remote. And then it does have some kind of stats, and you can have some kind of config that if something that is showing some attacker's pattern different to the usual way that your application behaves in these numbers, then you can define actions like terminating a session, or like invalidating tokens, or like locking a user account, or simple things like increasing log level for forensic analysis stuff, etc., or blocking IP addresses temporarily, etc., etc., etc. So it's all about insufficient logging and monitoring. And this is something that's now, at least in the latest top 10 of the OWASP Web Application Security Project, definitely that we need to have some effort spent in terms of detecting successful breaches. Last part, missing breach preparation incident simulation drills. How many of you did ever a fire drill, Brandschutzübung? No, we have to go out of the building. Okay, good. Don't take the elevator. Important, very important, very important. Might save lives. How many of you did a IT security incident simulation drill? 1. Yeah, 2. How many office buildings burn down a year? Hopefully not many. How many systems get hacked a year? Unfortunately, many. So definitely we should do something like this as well, including obviously the Brandschutzübung stuff. This is about red team versus blue team. So to simulate successful attacks that you can test your emergency response procedures. So what to do on a successful hack. Quickly isolate systems to block the data exfiltration. Forensic analysis of those isolated systems. How got the attacker in? Where did the attacker pivot into your internal network? That you get indicators of compromise from your system, that you need to scan then your whole infrastructure if something else was compromised in the same style. You need to check traffic amounts, even historical things, including DNS for out-of-band exfiltration, etc., etc., etc. And last but not least, this could be very important, to rotate all the crypto keys, all the certificates, all the credentials that might be considered compromised. Could be very, very, very important. So I have a checklist for this ready. Basically, we do have some inspiration here from NIST, bit of old, but still good, or Bundesamt für Sicherheit und Informationstechnik, Behandlung von Sicherheitsvorfällen, how to handle security incidents. It's a matter of the Brandschutzübung kind of thing for IT security. Cyber, if you name it that way. Cyber Brandschutzübung. It's a war game exercise. So the lessons learned from that is usually something like, we need to have better logging here and there. We need to have better traffic monitoring of DNS, for example. We need to have quicker crypto key rotation, credential rotation. We failed on this. Certificate revocation, etc., etc., etc. 2 ways of learning: the hard way on an actual breach. That's bad. The good way is as a planned exercise in a simulated information security drill. This was the 7th sin I see in agile projects, missing of breach preparation. So I hope you liked the talk. We do have 3 things as call to actions for you in the next 3 time frames. So in the next week, identify your gap by checking those 7 sins and elaborate which of these sins is the most important, most relevant, most prevalent for you. Within the next month, define some action steps to get some improvement done there. Do it. And within the next year, you should define a roadmap for the remaining other gaps, buy the management in, get the management to buy in, and then scale across the teams of a corporation. Good. I hope you like this set of fully fledged information in these kinds of 100 and something slides. You can get them from the conference. You can also website get me an email. Here you've got my business card if you do have any questions of this as well. And I'm happy to send this to you. Otherwise, I say thank you. And later we can do some question and answers, but I would like to finish on time because we've got another speaker waiting. Thank you.